Hi all. Also, welcome to the session for week 5, and let's get started. Yeah, please log into the Menti account with this code. Come on, everyone. Only 19 people have joined as of now. Please be a bit fast.
Am I already joined?
Okay, great. Okay. So first, you need to tell me if you watched the lectures for week 5.
Yes, ma'am.
That's nice. Would anyone like to share any comments regarding the concepts discussed in week 5? Okay.
It's about supervised learning in KNN algorithm usage and real life applications on that how are we going to solve the problems in real life using KNN.
Correct. So what do we understand by supervised learning?
Ma'am, supervised learning is when we've given labels.
To make like any predictions or to classify the data set into something, right? Okay, so the very first algorithm that is discussed in week 5 is about KNN, which is K nearest neighbors. So would anyone like to tell in brief what that is about?
KNN is when we calculate the distances of the test data with the training data, and we sort the distances from the least to the most, and then we choose some of the distances, and then we give the label to the test data according to the majority of the labels in the number of distances we have taken.
Okay. So you said that we choose some of the distances. We don't choose the sum. I mean, do we choose any
No,
distances
ma'am.
at
I said
random or do we choose like the minimum of all?
Ma'am, the minimum. I said some of the distances and then few of the distances according to the K we've taken.
Correct. So that is about your KNN. And depending on what the K is, like 2, 3, 4, whatever, you tend to take so many distances and then assign the majority label to your test point. Now there is a case where, this algorithm can overfit and subsequently it can even underfit. So can you tell me, if I choose a higher K, will it underfit or overfit?
Oh,
So you're saying that if I choose a higher K, it's gonna overfit. Do everyone agree with that?
Yes, ma'am.
Think again. Because choosing a higher K means that you are like taking a lot of points into consideration. And suppose your K is equal to the number of data points in the set. So each time you're gonna assign the majority label only to the test point. So is that
I
overfitting
think,
or underfitting?
ma'am, I think if larger the K, then it will be underfitting behavior.
Yes. Because as I just said, if you're taking K to be equal to the size of your test set, sorry, the training set, which can be the maximum possible K, right? Now, if you're choosing that a big K, so every time you're gonna assign the very same label to each of the test point. So where is the learning, right? That is why we say that the model is underfitting in this case. And consequently, if you have a very small K, it means that only one closest neighbor is deciding your test label. And there you are even fitting the noise and outliers. And then that becomes the classic case of overfitting. Okay, so that was a very brief recap of your KNN. Yes, Shalini? Okay, we'll see more algorithms as we go along. Now, here are a few questions for you. So please click on this link and there you will find some questions. I hope people are able to access the questions.
Ma'am, I wanted to ask, are you showing the questions? Okay.
Yeah, I'm showing them now, if you're able to see the screen. Okay, so you must have visited this link. Here you will get all the questions and together with a few definitions. So classifier, as we all know, we have a test data point. We pass it through a classification model, and on the basis of the outcome of whatever the processing is going on, we get a final decision in the form of a yes or a no, or 1 or 0, as the case may be. And week 5 deals with 3 types of classifiers. One is KNN, decision trees, and neural networks. KNN we've already discussed in brief. Okay. So this is your training set here in terms of your green and red points, and the black point is what we call your test point. If we choose the value of k as 3, it will consider the 3 closest neighbors, which are these 3 in this case, and then it will assign the majority label, which in this case is red. I hope everyone understands this. So this is your question number 1, where you have this training set in terms of green and red points. You have a black test point. K is equal to 5, and you need to tell me what will be the predicted label, whether it will be green or red. Okay, please mark it on the Menti. Let me also show you question number 2 before going back. So question number 2 is about the distance between the black point and the point farthest to it. So there are 8 points here, 4 green and 4 red. First, you need to identify which is the farthest point from this black point, and then you just have to give me the Euclidean distance for the same. So please solve these 2 questions and mark your answers in the Menti. Go to this very link, okay? You can access the questions here. Okay, for question number 1, I have red as the majority answer. Which indeed is correct. Okay. And this is a question number 2. Here you have to calculate the distance between the black point and the point farthest from it. Yes, 5 is the correct answer here. Now let me show you question number 3. So here, this was your test point, and the point farthest from it is this 4, 0. And then 4, 0 and 1, 4. If we take the Euclidean distance, it will come out as 5. And question number 1, if k is equal to 5, the 5 nearest points, as we can all see, is 1 green here and all these 4 red. So the majority says red, and that is your label. Now, question number 3 is, what is the predicted label if k is equal to 8 is used in the above graph? So here, if I put k as 8, which is also the size of my training set, what will be the label? There are 3 options, green, red, or green or red. Okay, so the correct answer here is green or red. For everyone marking green and red separately, is there any reasoning to it?
Ma'am, it can lie in any of those 2 points as we take k value as 8.
Yeah, so K value is 8. So basically you're considering all the points, right? And in your entire set, there are 4 red and 4 greens. So there is no clear majority, and that is why it can either be green or red. So here the only correct option is third one. We cannot say, by certainty that 100% is going to be green or 100% is going to be red. So the first two options are not correct that way. Okay, so now we'll start with the questions from decision trees. But before that, let's have a brief discussion. Okay. So would anyone like to throw some light on what decision trees are?
Ma'am, decision trees are when we compare the test data to all these parameters and we decide whether it's a yes or a no.
Okay. Anyone else?
We just classify the questions depending on our training set and just ending up in the leaf nodes.
Correct. So this is how a decision tree looks like. Now this is another popular classification model. As the name suggests, it's a tree. And in a popular computational tree, we have something known as the root. So root is where you start, basically. So here the root is this node N1. Then you have certain intermediate nodes. Here we are calling them question nodes. And then ultimately you have your final answers in the form of your leaves, which are known as leaf nodes, okay, which are here hanging down. Now, what you do is at each question node, you have some parameter or feature, okay, and there's a condition that you check. So here I'm checking if x1 is less than 5, x2 is less than 1 here, and x2 is less than 3. And if that condition is satisfied, you go along a certain path. If that is not satisfied, you go along a different path. So you keep doing this and you keep traversing the tree. Each time you check the condition, okay, on the basis of the parameter or feature under consideration. And correspondingly, you keep traversing the tree until you reach one of the leaves. So here you have how many? 5 leaves. So until you reach one of the 5 leaves, you keep traversing the tree. And then once you reach the leaf, whatever the leaf says as the label, that becomes your final answer. Okay, so this is the general setup of a decision tree. It's made up of several nodes. As I told you, it has question nodes and leaf nodes. And each question node is of the form of a feature less than a value, or it's basically a condition. So you can have any relational operator here. And there's a feature or a parameter, okay, like all the columns
Okay.
that you have basically in your training set, that is what we call as the features. Then nodes that do not have questions are the leaves basically. Okay, and leaves are what give you the final answer. And the topmost node to begin with is your root node. So it's quite interesting. Okay, and just be careful with the questions that you're asking. Be careful with what the condition has to suggest, and then just traverse down the tree in a logical manner, and you'll be able to reach the answer. So, question number 4 is how many leaves does this above tree have? Okay, and you can just put the answer in Menti. You need to count the number of leaves in this very tree. And here, as I was telling you, that we traverse the tree, we start at the root node, we keep asking questions and conditions, and then we end when we reach a leaf node. So this here we are predicting the label for test point 0, 0. So 0, 0, here this is x1, 0, and x2 is again 0, okay? So x1 is less than 5, yes, because x1 is 0. So we traverse here. Then it says that is x2 less than 1, which is again yes, because x2 is 0. So then we come here and we end up in red leaf. So the answer becomes red. So this is how you traverse a tree. So your question 4 was, how many leaves does this tree have? And your question number 5 and question number 6 are same. These are about traversing the tree. So question number 5 is asking you, what label will the point 0, 5 have? And in question number 6, you have to tell me what label will 6, 1 have. Okay. So you can put the answers in Menti, but I would like someone to just unmute and tell me here itself the answer to question number 5 and the answer to question number 6. And take me through the entire tree and let me know how you arrive at the answer. So what will happen in case of 0, 5?
Ma'am, in case of
It's
0,
green.
Yeah, go ahead.
First, we will check the value of x1 compared to 5. It's 0 and it's less than 5, then it's a yes. Then we'll go forward in the yes direction.
Okay.
And then we'll again check the then we'll again put 5 there in the place of
So
x2.
basically, we have come here. Okay.
Yes, ma'am.
Now,
We'll put 5 in the place of x2 and it's false condition, so it will go towards no.
okay. So this is
So
where
it will be
I'll
green.
end up with, right? Green leaf.
Yes, ma'am.
So the predicted label for 0, 5 is gonna be green. And what about 6, 1? Somebody else?
It is also.
You basically have to take me through the tree.
First it will check for x1 and which is greater than 5. So we will go to its no
Okay.
side. Then x2 is less than 3 because it is 1.
Okay.
Then we will go to his yes side. Then the 6 is less than 8. So we have to go to his yes side. So we end up getting the green.
Correct. I hope everyone follows that, and the answer to both the questions is green. Okay. A random question here. What about 5, 5?
It will be red.
Okay. So first it's gonna go to this no direction. Then again, no. Correct.
ma'am, I don't understand why that's happening.
The 5, 5 or
Yes,
the
ma'am,
other?
5, 5.
Okay, so you're starting from the root here. Is 5 less than 5? Yes or no?
Oh, okay, ma'am. Yes, ma'am, I understood.
Okay, so then you come here and then I think it's straightforward from here. Okay, how many question nodes do we have here?
4.
Yes.
3.
Please also include the root node in the question node because it indeed is a question node.
Then 4.
Yes. Okay. Then we have something known as the depth of a tree. So what do we understand by depth of a tree?
The maximum possible distance, like the maximum possible value, like least downward.
Okay. The maximum possible, maybe you mean the number of questions and the path that we are taking to reach a leaf.
Yes, no.
Okay. So here this purple marked path is, I think everyone agrees, is the longest. Either this or this, even this one. So that is why the depth for this is 3. And how do we count that? Just count the number of arrows. So 1, 2, and 3, that gives you the depth. And there's also the concept of the maximum or the longest path. And I think that again is straightforward. This is how you define the path. Now, for when asked to define the path, you define the path in terms of the names of the nodes. So I think this was N1, this was N3 or something. So you'd say that the longest path is N1, N3, N5, okay, and stuff like that. Okay. So I think question number 7 we've solved already, that the depth. Okay. This is about a new tree. So question number 7 is asking you to calculate the depth of this new tree here. Okay. Please calculate it and put the answer in Menti.
We haven't answered the previous questions, I think.
Yeah, I'll just show you the screen. We actually have already discussed this, so is this the question or was it question number 8? Yeah, I think this only. You have to tell me the depth of that tree. Right. 4 is the correct answer here. Okay. Now, few questions on the basis of decision trees. Suppose the depth of the tree, see, it's a hyperparameter, okay, and it's something that you get to decide beforehand. And now again, from an overfitting and underfitting perspective, what do you think that if I choose if I choose a larger depth, will that underfit or overfit? And also give me the reasoning supporting your answer.
It will be underfitting because
It's
if we just keep
overfitting.
on,
Okay, one by one. First let the first person complete.
Okay. I think a larger depth in decision tree, maybe it's overfitting.
Okay, what's the reasoning behind it?
It keeps splitting until it almost memorize the training data or something, maybe. But the trees
Yeah.
becomes
I mean, you're
complex.
asking so many questions and making so many splits, so it's
Yes,
basically
ma'am.
getting like your model very, very complex. And even
It's
maybe very
complex.
simple decisions, you might have to ask like 25 questions. So that's obviously overfitting. So if I increase the depth and if like I keep it unhinged and if I just increasing it till it perfectly classifies all my training points, that's gonna be the case of overfitting, and it's also gonna overfit any noise and outliers which are there in the data. And on similar lines, if suppose I only ask 2 or 3 questions and like take my depth as 1 or 2 max, so that's again like I'm asking very few questions or the architecture of the model is very simple. And then in that case, we will say that the model is underfitting because it has not really learned uh, like the whole lot of relationships and patterns that are actually underlying the training set. I hope everyone understands that.
ma'am, I have a doubt. Why is a larger value in K in KNN is underfitting while a fewer question here is the converse?
Yeah, see, because it lies in the intuition and the basic uh, architecture of your algorithm. So you don't have to, like, it's not a rule of thumb that if it's a larger value of anything that translates to overfitting. No, you need to understand it logically. Now, what is happening in KNN is, if I'm taking a larger K value, it's considering like a lot of points in my data set, and then taking the majority, like what was happening here. Here, when I said that take K as 8, okay. Now, no matter where my test point is, right now it's here at 1 comma 4. Suppose it's at 8 comma 4 or 7 comma 2. No matter where it is, because you have chosen K as 8, every time, because it's like the majority, there's no clear majority, so you can either say green or red. Or suppose if there were like 5 greens and 3 reds, so every time, every test point, you would have only allocated green label. So this is why I say that a larger K in KNN is underfitting. Why? Because you're taking so many points into consideration that the underlying relationship between the points or the underlying structure is missing, because now you're taking so many points together. But if I
Ma'am,
say
what do you mean by the underlying structure?
underlying structure as in, see here. Here, if I am saying that, take K as 3. So the structure is that 2 points are closer and like 3 points, these are closer, out of which two are red and one is green. So then you assign the label as red. If I here again say that you take, how many points are here? 1, 2, 3, 4, 5, 6, 7, 8. So if I say that you take K as 8 here, what the algorithm will do? It will count all these points, okay? It will take them in a bag, right? And it will say that there is no clear majority in between green or red. So it's gonna assign either green or red. Or maybe for sake of simplicity, let's assume that this point here, 3 comma 0, is green, okay, instead of red. Now what is gonna happen is, if I say that take K as 8, every time, because it's taking all the points, the majority will always be green, no matter where my test point is. So the structure is lost. As in, what do I mean by structure? Because I'm taking all the points, okay, and so all the 8 points are closer. And the structure, as in the underlying structure, like here, if I take K as 3, so now the underlying structure that, okay, these 3 points are more closer, and that is why the majority should be decided by the only 3 closer points, and the label should be assigned accordingly. That is my structure. But if I'm taking all the points together, it's like putting everything in a bag, okay? And then because all the 8 points, there are only 8 points here. So we are not talking about which is closer, which is farther. So there is no structure remaining. And now you're not learning any structure, nothing. You are just playing you're just putting everything in a bag and just checking the majority label and assigning it to your test. So no learning, no structure. And that is why we say that it's underfitting, because it's not learning anything. So here in case of KNN, a larger K leads to underfitting, whereas a smaller k, suppose if k is 3 or 4, so now you can check, okay, these 3 points are closer or these 4 points are closer. So majority should be decided by these three only. So here you're at least learning something, right? So that is a case of, I mean, that is your normal case. But if again you choose k to be very less, like k as 1, then that might overfit. Why? Because suppose this point here, red, this has been like this is the noise, right? And this is the outlier, and it should be green, suppose. But now because my k is 1, and suppose if I'm taking this point as the closest neighbor, although the closest one is this one, but you just understand, for the sake of understanding what I'm trying to say, then it will say that no, the point is red. But it was the noise that you have fitted now, and that is why it's the case of overfitting. So this is the difference between your KNN and decision trees. So in KNN, a larger K leads to underfitting, whereas a smaller K leads to overfitting because you're then also accounting for the outliers and noise. And in case of decision trees, the algorithm is classification. It's also classifying like KNN, but the architecture is very different. Here you have nodes, you're asking questions, then taking decisions, okay, on the basis of that. Here you are not playing with your closest distances and all that KNN stuff. So here you have to think logically in terms of how the trees are gonna work. And now here in terms of depth, if I keep increasing the depth, what do I mean by increasing the depth? It just means that I'm asking a lot of questions. So if I'm like I'm asking how many? Four questions max, right? On my two features that I have, x1 and x2. Now suppose I'm asking 25 questions on my x1 and x2. So it's like your model becomes very complex. Even for a simple point, you're asking 25 questions that is this less than 3? Then is this greater than 8? Then is this less than 0? Right? So your decision boundary is becoming very complex. And even for a small task, you have to ask so many questions. So that is the case of overfitting, that unnecessarily you're asking so many questions and making the model complex. And at the same time, if I keep my depth as very less, like just one or two, where I'm asking like just a one simple question, then again, that is the case of underfitting, because suppose if I just have this root node here, that is x1 less than 5, okay? I just have this and I cut everything off, right? Here, like all these questions just go away. So I just have one question, x1 less than 5. Yes, no, and here I have a red and here I have a green. Okay, so just one question with a red and a green. Now, if here I'm giving you the point as 0, comma 0, that will also be green. If I'm giving you the point as minus 5, comma something, that will also be green, because everything that is less than 5 will be green only. So again, you are not learning anything much. There's just one condition that you are making your decision on. So that is why if you're keeping the depth as very low, okay, or asking just one or two questions for that matter, it means that the model again is not learning much, and that is why it is underfitting. So please think in terms of what the model is doing, how the architecture is, what the algorithm is logically about, and then decide whether a larger value will overfit or a smaller value will overfit. Please don't make it a rule of thumb that if it's a larger value, it will overfit only. No, because as we just saw, it's the opposite in terms of KNN and decision trees. I hope there's some clarity now. If that is fine, then we move to neural nets. So again, a question to you only. Please let me know what you understand by neural networks.
I know.
Yes, Sakti Saran.
Ma'am, in neural networks, there's an input layer and there's an output layer, and in between there are hidden layers. And basically, we assign weights to all of the features, and on the basis of that, we give probabilities for the outputs.
Okay.
I didn't understand it much. This is what I could gather from the videos.
So there's an input layer, then there's an output layer, and there are hidden layers, and then we have weights and edges, and then something is going on, and then you get a final output.
On the different hidden layers have different weight for the different inputs we give, and till it reaches the output layer, they will just combine the weights between them and give out the required output at a probability.
Correct, correct.
Ma'am, I
Uh,
can't understand this one.
okay. So this is how your neural network looks like. It's again a classification model. Now you start off here, okay? This is your input layer, the very first one, okay? Here you give your input. Then you see these edges here. It's like a very vast network, okay, of these edges because every neuron in one layer is connected to every other neuron in the subsequent layer. So if here I have like 7 neurons in my hidden layer 1, so I will have 7 edges up like coming out from my first neuron here and similarly for all others. Now what will happen is you've given your input here, okay. Now it will travel through these edges. So the input which you have given in the first neuron, it will travel through the first 7 edges. Then correspondingly, from the second neuron, it will travel through the next set of 7 edges. So it keeps traveling through these edges. Now these edges have something known as a weight. Weight is the number which is associated with it. So what happens is, suppose here I give input as 3, okay? Suppose here I give input as 3 in the first neuron. And then I have 7 edges connected to this neuron. And each of these edges is having a weight. Suppose, for the sake of simplicity, suppose the weights are 1, 2, 3, 4, all the way up to 7. So what will happen is, my input 3 will get multiplied by the weight. So for the first edge here, it will be 3 into 1, 3, okay. Then the second edge here, whose weight is 2, it will be 3 into 2, 6. Then 3 into 3, 9. Fine. So what you do is you first multiply your input and the weight of the corresponding edge. Then there are 7 edges, right? Like from each of these which are outgoing into the second layer. So what you've done up until now, you took the input and you multiplied with the corresponding weights of all the edges. So you will have the multiplied entity corresponding to all the edges that are there. Now what will happen is, see this neuron here. I hope everyone is able to follow my cursor. So now see the see the first neuron in hidden layer 1, which is the second layer here, okay? What is this neuron doing? First of all, it is having some edges which are incoming to it, okay? Now, how many edges are incoming? Question to you.
7,
Logically tell, or
6,
how many? 6.
7. 6.
Yeah, 5, 6 or 7.
I think it's
6, ma'am.
6,
It's
6.
6.
Yes, because this neuron is receiving an edge from each of the neurons in the layer which was preceding to it. Now, in the preceding layer, there were 6 neurons. So, it is receiving 6 edges. But when I was talking about the first neuron in the first layer, it had to go to the second layer, which had 7 neurons. So it needed 7 edges. So I mean, it's basic logic. Okay, depending on how many neurons are in the subsequent or the preceding layer, those many edges you have. So for this neuron here, first neuron in hidden layer 1, you are receiving 1 edge from each of these neurons. So there are 6 incoming edges. Now what will happen is, remember I told you that here you multiplied. So like it was 3, so you did 3 into 1, then 3 into 2. Now you did that all across. Like I told that for the very first neuron. But suppose here you had, suppose 10, okay? And then the edge weights again, for the sake of simplicity, were 1, 2, 3, 4, 5, 6, 7. So 10 into 1, 10 into 2, 10 into 3. So you did this for all the neurons and all the corresponding edges, okay? Now what will happen is, for all the edges that this neuron is receiving, okay, this first neuron in hidden layer 1. So it is receiving one edge from this neuron, one from this, one from this, one from this. So suppose here the multiplied entity was 3, okay? Here the multiplied entity 10 into 1 was 10, okay? Then the third neuron, suppose the input was 20 and the edge weight was 5. So 20 into 500. So it's receiving all these numbers, 3, 10, 100, okay? All those multiplied entities, 6 of them it is receiving. What it's gonna do is, it's gonna take those 6 values and it's gonna simply sum them out. So 3 plus 10 plus 100 plus whatever, okay, 6 of those values, it will take, which are coming from these 6 edges, and it will just do a simple sum, okay, and suppose the sum is 200. So now here for this neuron, the new value is 200, okay. Now once this value is 200, now it will do the exact same thing with these edges and these neurons that are upcoming. So now this 200 is like the input value to this neuron. Then again, these edges will have some weight. Suppose this has 1, 2, 3, 4. So 200 into 1 or 2, like 200, 400, 600, something like that. Then again, same story. This neuron is receiving the edges, okay? Now here you had 7 neurons. So this one neuron in the third layer will have 7 edges. It will receive some multiplied values. Okay, it will add everything up and that added value will be its input. Then again it will multiply, and so this will keep happening and happening and happening until we reach the final layer. So here in this output layer you have 2 neurons, okay? And in the preceding layer you had 4. So one neuron here will receive 4 edges, one from each of these 4 neurons, okay? And whatever the multiplied entities these edges carry, it will just add them up and it will give you some value. Suppose that value became 500 here, okay? So that 500 will become your final answer. So, I mean that this is how a neural network largely works, and this is how the one forward pass is done. So you start at the input layer, you have the edges, you multiply everything, then you have the second layer, you take those edges, okay, only those edges which are relevant for that particular neuron, you add the values up, those added values become the new inputs for this layer. Then you repeat the same story for all the hidden layers and you keep doing this until you reach your leaf node. So, it's like your decision tree only. It's like decision tree, you do it like 100x. Okay, and now in decision tree, you had a simple yes or no. Suppose here I also like put some weights and something, and like I just increase number of nodes considerably. So something around that. So this is how the basic architecture of a neural network looks like. And don't worry, this is a very advanced concept in machine learning and deep learning. So you won't be tested on a lot of things. Only, you should be only understanding the basic architecture, that we have an input layer and output layer. We have hidden layers, how the processing works, okay? And how many edges and how many weights and how many, like the basic processing step, which I told you, that you multiply and add a into x plus b, okay? That is the basic equation. So only this much is required at this level, because neural networks in itself is a very, very advanced topic. And currently you're not at that stage where you'll be able to understand everything. So just understand the basics and you'll be good to go. Okay. So neural network is a classifier made up of a number of layers. Circles are the neurons, as I told you. Then you have an input layer, output layer, and in between we have the hidden layers. So to make a decision, we pass the input, okay, at the left, you pass the input here. And once it goes through all the edges and, does all this pre-processing internally, then you obtain the final output at the like the rightmost layer, okay? And this one pass is known as a forward pass. So again, don't get confused with the terms, because when you are actually studying machine learning, what we do is, once we do a forward pass, okay, we then we like calculate something known as the gradients or the derivatives. And to calculate gradients and derivatives, what we do is we reverse the process. As in, we make this layer as the input layer and this layer as the output layer. And then we start from here and go in a backward direction. So from here we'll go to this layer, then to this layer and this layer. So that is what we call as the backward pass, okay? And that is basically your back propagation algorithm. And that is just to make your model, more optimized and more refined. But again, that's again an advanced concept, and I'm not going into the details of it. So you just understand that whatever we did here is something known as a forward pass. The neurons are connected by edges, and each edge has a weight or a number associated with it. And this weight, it denotes the strength of that edge. So I hope you understand this. If there's any question, please let me know. Else we can discuss these questions.
Ma'am, can only numbers be trained or used as a training data set, or can we use text and image also as a data for neural networks?
Okay, good question. So we can use like both text, images, everything. But again, coming down to how your computer does the pre-processing. So, I mean, a computer only understands 0, 1, okay, or numerics for that matter. So, yes, the answer to your question is yes, it can process text and images. But for that, it will first convert the text and image to a numerical vector, okay, and then there's a full theory behind it that you have your tokenizers and all of that stuff, which will convert your text and images into vector embeddings. So again, not going into the depth of it, but just understand that it will first convert everything into numbers, and then it will do the processing as it does it for like numerical data. Okay, if that is clear, if there's any question, you may ask me. But if this much is clear, so these are the three questions. One is simple, how many hidden layers does this network have? Then second question is, how many weights does this network have between the input layer and the first hidden layer? And the last question is, what is the total number of weights in this network?
Ma'am,
Yeah.
how to answer these questions in which app?
Uh, you can answer them in the Menti, and then I'll also discuss it otherwise. But I hope you've joined the Menti.
Yes, ma'am. Ma'am, 1 minute, ma'am. Can you share me the link,
The link to what?
the app, sir, to the
You
Mentimeter?
can just use this code if this is visible. Just log into Menti and just fill in this code, and you'll be able to see the screen.
Can you wait for a minute?
Yeah, yeah. So people say that there are two hidden layers, which is the correct answer, of course. Okay. This is your question number 9. This is about how many edges or weights you have in between the input layer and the hidden layer 1? Please answer this logically. Okay, people say 42, which is the correct answer again. I'll just discuss this in a while. And this is the question 10. You need to calculate the total number of weights like across the entire network. Yes, 78 is the correct answer here. So I hope people are able to see clearly that we have two hidden layers. Then for the weight, like number of weights calculation, what logic do you use? Anyone? If I wanted the number of
Weight
edges
for
of weights
each
between.
layer and their sum.
Okay. Suppose this is my input layer and hidden layer 1. So how many black these lines are there? Like what is that simple formula which you're gonna use?
It's,
I'm
I
just
think,
multiplying the number of the number of neurons between the two layers.
Okay, 6 into 7.
Yeah, between those two layers, 42 weights are there.
Correct. I hope everyone understands this, that just take, like, because I told you that one neuron is connected to every other here. So 1 into 7, 7, and then there are 6 of these. So 6 into 7 makes it 42. And on similar lines, the last question was about total number of weights. So you just repeat this activity for this bunch here, and then this bunch here, and then just add everything up, you'll end up with 78. So here you will do 7 into 4, okay, 28. And here you will do 4 into 3, 12. And then when you will add up everything, you will end up with 78. Okay, I hope this is fine with everyone. Okay. So here, because we are dealing with a very simple classification problem, yes, no kinds. So here, like I told you, it can be 500 or something, but for your case, it's gonna be a green or a red. So a yes or a no at the output layer, okay? Either the above one could be a green, the lower one could be a red, okay? And then depending your input, it can end up in either of the two neurons after all the processing that's going on here. So accordingly, you will assign the label. Now here again, the last question is, if currently I have like 2 hidden layers, then again, if I increase the number of hidden layers, will it underfit or overfit?
Overfit.
Okay. Yes, that's right. And what's the reasoning?
Complex situations will take place.
Yeah, I mean, if you're increasing the hidden layers, so this complex story
Ma'am,
of
we are just complicating the number of weights we are measuring, and it just keep getting complicated, complicated, and complicated.
correct. So now you're like performing a whole bunch of new operations and multiplications and additions for a lot of layers compared to the 2 here. And that is why it's like unnecessary or complex calculations, which will overfit your model. And on the other hand, if I just have like 1 layer, so the calculations might be like they might be less and they might not be sufficient. Okay. So in that case, we'll say that the model is too simple or the model is underfitting and not able to really capture the relationship or structure in terms of sufficient number of calculations. So every time whatever the depth or the K or the number of hidden layers you're choosing, you have to choose a moderate, balanced value. And normally I've seen that 3 is the number which people wish to go for. So, I mean, that's quite balanced out. So for starters and as beginners, 3 is the hyperparameter that you should aim for. Okay,
Can you
so
tell again? I couldn't get you.
yeah, I was just saying that, like, you choose the hyperparameters, right? Like, what should be the depth of the tree, what should be the number of hidden layers, and what should be the value of k and n. So, a safe value is mostly 3 in most of the problems. So, I mean, people go for 4 as well, but 3 is the most popularly accepted. If you go beyond or above that, so it might underfit or overfit. So 3 is like an average, moderate, balanced out value. So that is largely accepted. Okay, so that brings us to the end of this discussion. If there are any more doubts, you may let me know. Else we can close the session. And I hope it was useful.
Yeah.
Yes, Harish.
Can you share the screen again?
Okay. Yeah.
Shall you teach me an KNN and classifier around again?
I mean, which one of these 3, or you're asking for every?
No, ma'am, that classifier K and that S one, this three, no, for the first two, KNN and decision.
Okay. I'll just give you a very quick brief. So classifier, I hope you understand that we are taking a test point as the input. Then there's something, the processing machine or the classification model that we have in between. And towards the end, we're going to get a final decision as 0, 1 or yes, no, as the case may be. And it's supervised learning, as in while we are training, we do have the labels with us. Uh, like unlike your unsupervised algorithms like k-means clustering, etc. And I think neural networks, so I already did tell you KNN and decision trees, we did have a discussion towards the beginning, but I'll just repeat. So in KNN, what is happening is you have the training data laid out here, okay? And the algorithm is simple. It says that I have my training points, okay? I'll just plot them out on some graph paper. Then what I'll do is, in KNN, whatever my test point is, I'll see how close it is, okay, to my training points. And then depending on the value of k that I have, I'll choose those many closest neighbors and I'll take the majority of the labels of my neighbors and assign it that value. So honestly, this is like a very simple, like the very first raw, simple classification model because here, honestly, you're not doing anything much. In decision tree and in neural networks, if you think nicely, there's a complete architecture that this is input, this is output, this is how we are traversing in between, these are how the calculations happening. But in KNN, it's like, it's just a very simple workaround that, okay, I have all the points. Let me bring a new point and let me just check the distances. There is no architecture, nothing like that. Okay, you're just checking the distances, checking the minimum distance, and on the basis of whatever the value of k is, you are assigning the majority label. So there's no architecture to the algorithm for that matter. And on the basis of the k, like here k is 3. So these are the 3 closest points, 1 green and 2 red. And since the majority is of red, you will assign it red, the test point. So this is how your simple KNN works. And
Black
depending,
is denoted as red point. Sorry, black is denoted as test
black
point.
is your test point.
Okay.
Yeah.
But another red point is also on the 3.
Sorry, I didn't get your question. Another red point is?
On the 3, ma'am, number 3, like in horizontal line 3.
Okay. No, what do you under? So suppose if I'm saying k is 3 for this black point, okay? Forget wherever these points are. You need to tell me the 3 closest neighbors. What are those?
Which one, ma'am? Near the point 3.
No, you have the test point, right? So you will have to tell
Yes,
me the
ma'am.
neighbors of the test point. Now for the test point, this black one, the 3
Yes, ma'am.
closest
The 1
points
comma
are this, and this.
1 comma 2, 3 comma
Mhm.
2, 4 comma 3.
Correct. And now out of these 3 points, the majority is of red, so you'll assign it red. Now this point will not be considered, until maybe I can change it to 5. Because if I make it k equal to 4, then I think the points that you're gonna take are this, and this. Here, 4 comma 1. So
Yes,
then
ma'am.
you will decide on the basis of that. This point will only feature if I make it 5. Then these 5 will become the closest points. And then likewise, I can keep increasing the k. I hope you understand this.
Yes, ma'am. Yes, ma'am. I understood.
Okay. Any other question?
Yes, ma'am.
Ma'am, I
Um,
have a doubt.
Mm-hmm.
Another after the K and algorithm, another topic is the second topic.
Okay. I'll just discuss that.
Decision trees.
Hmm. Yeah, just somebody said that they have a doubt. What is it?
Ma'am, actually, we have assignments, right? The mark of the assignment is fully based on only the questions that we are answering in the assignment, or something else also counts.
No, only the questions that you're getting right in your assignment is what matters.
Where to answer the assignment?
You just have to, it's like an MCQ, right? Just have to select the correct option in the portal and just click submit towards the end and it will be submitted.
For me, the link is not opening. So, which link? I'm confirming the link. Which link, ma'am?
See, are you asking about the course portal? So there's a different link for it. I mean, everyone must be having access to the portal. So here you have your assignments. You just have to put in your answers and submit. Nothing else is expected of you. Right, so I'll just quickly discuss the decision trees and then maybe I'll close the session. So in decision trees, this is now how your architecture looks like for the classifier. You have something known, so because it's a tree, so it's in a tree-like structure. You will begin at the root node, then you have some intermediate nodes as the question nodes, and finally you will end up in the leaves or the leaf nodes. And here it's like at each node, you're asking a set of questions which are dependent on your feature or parameter values and a condition around that. Okay. It's like your conditional if else statement in Python or any language that you write. Okay. And on the basis of that, you either have a yes or a no, and then you keep traversing the tree until you end up in one of the leaf nodes, and then that becomes your answer. So here, suppose my point is, so this is how my tree structure is. Okay, this is my model. These are my questions, which will not change. So, okay, so these are the questions that I fixed, and these are the outcomes that I fixed, and this is how my decision tree model looks like. Now, suppose my input is 0, 0. So you start at the root node, 0, 0, 0 is less than 5, yes, you come here. 0 is again less than 1, yes, you come here. And then it says red, so your answer is red. So this is how you traverse the tree. You start at the input point. You keep checking the questions. On the basis of the condition, whether it's a yes or a no, you land
Ma'am,
at...
this
Yes.
um ma'am, if you
Yeah, so you land at the corresponding nodes and finally you predict the label. I mean, if you have any specific question, Harish, please let me know, because that is the overall, like the overview of this.
yes, ma'am. The third topic is neurons.
Neurons are just discussed
No,
with, right?
yes, ma'am. But it works on binary, right? That number one. Actually, it works on which basis, ma'am?
Can you please repeat your question? Sorry, but I'm not able to
And
understand.
this whole
Mhm.
pattern works on basis of which pattern?
You're asking that the multiplication and additions that we are doing, like what's the logic behind that, or?
Yes, ma'am. The logic is multiplication, right?
Yeah, I mean, you were asking that why are we doing the multiplications and additions?
Like, yes, ma'am.
Okay. See, as I told you, it's I mean, this is your structure, and what you have to do is this is one layer, second layer, third layer, fourth layer. I mean, intuitively, you know that somehow you need to start at one layer, you need to then travel through the edges in some manner, then reach the second layer, then do the same thing again, and then finally end up here. So, this traveling process, as in how am I gonna go from one layer to the next, and what path and what equation or what calculation am I gonna use, that is what we decide. So this neural network, a simple neural network, it is designed on the basis of this rule that I told you, that You take the multiplications and then you add. So it's your simple linear equation y equal to mx plus c. So a neural network is designed on that very simple calculation. Because as I told you, if this is the architecture and you have to somehow take a forward pass, you need to come up with something that, okay, what should be the logic that I can go from first layer to the next? And what can be the logic? There can be multiple logics again. I can also say that, you take, like you introduce quadratic equations here, that whatever the inputs are coming here, instead of just adding them up, you first do the squaring and then you add. So there can be multiple things. But why to complicate things so much? That is why when neural networks were designed, they used a very simple, like the simplest of calculation, I think, is this only, that whatever the number is, you multiply, okay, with the weight edge. I think that's the most simple and the most intuitive thing that you can do. And once you reach a subsequent neuron, you can simply add those up. I mean, there can be nothing more simple or raw than additions and multiplications. So neural networks were designed on a very simple principle. Instead of saying that, okay, you first multiply, then square, then take a square root and do all those weird things, they said, no, we'll keep things and calculations simple. We'll base our processing only on a simple linear equation, okay, for all the calculations that we will do. And if we need to introduce complexity in our model, so instead of making the calculations more complex, as in to say that you are doing ax square plus bx plus c, instead of doing that, you keep it at ax plus b. To introduce complexity, you can just increase the number of hidden layers. Because if you increase the number of hidden layers, the number of calculations will go up, the number of edges will go up. Okay, there will be like a bit more processing, and consequently your model will become a bit more complex. But the simple calculation will still stay at your linear equation of ax plus b. So that is how the neural networks are designed. They don't use fancy equations for each step. They only use the linear equation, because I mean that can be the very simple and raw calculation. And to introduce complexity, they just keep increasing the number of hidden layers to make the model complex, and they do not change the very basic logic of each step of calculation. I mean, this is how the people who actually like created the neural networks and came up with this paper and like all the transformers and everything. This is how they decided that, okay, we will keep it this way. Now, I hope it does make some sense and answers your question.
Yes, ma'am.
Okay,
Yes,
so
ma'am, I can understand. But I have one doubt about that IIT.
about the what?
After the sixth week, there is IIT program 4 year
Mm-hmm.
that project. Can you tell about the project?
Okay, so that I'll discuss in next week's session, and one more person will also be joining, so we can take that there. We are still like to
Okay,
finalize
ma'am.
the final like guidelines and everything, so I can tell you about that in the next session.
Yes, ma'am, yes, ma'am.
Okay, so I think we are good to go now, and we can close the session now. Thank you all for joining in.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.